the same thing as a turning point, right? So a turning point is where the graph is increasing or decreasing and then it turns the other way. So this is a cubic function, so it's increasing, increasing, increasing. It gets to that point, it turns and now it's decreasing. Then it gets to that point, it turns and now it's increasing. So this graph here has two turning points, right? Yeah, sorry. I meant to do that. Right, now I'm right, am I? Right, okay. So a turning point is where it changes from increasing to decreasing or vice versa, right? Okay, if it's just a U-shaped curve, right, there's just one turning point, isn't that right? Okay, so if there's a U-shaped curve like that, there's just one turning point, right? Okay, if it's a line, there's no turning point, right? Because it doesn't change, it's always increasing or it's always decreasing. Okay, right? So a turning point is where it changes from increasing to decreasing or decreasing to increasing, right? Okay, and the one that's up high is called the maximum turning point, right? And the one that's down low is called the minimum turning point, right? Okay, so the one that's up high is called they call it a local max because it's not the maximum of the curve. The maximum of the curve is way up there somewhere, isn't it? So it's called a local maximum because it's not the maximum of the curve, right? And it's called a local minimum. Normally we just leave out the word local, but just so you know, it doesn't mean it's the highest point on the curve because there is higher than it. Okay, are we good? Right, do you all know what a turning point is? Right, okay. And the rule is, look, if I was to draw the tangent at the turning point, what's the slope of the tangent? Yeah, it's 0. A horizontal line, the slope of a horizontal line is 0. As in, there is no hill. So the slope is 0. So basically, at the turning points, the slope is 0. So another way of saying that is, at the turning points, dy dx is equal to 0. That's a rule. The minute you see the words turning point, you write down dy dx equals 0. Because at the turning points, the slope is 0. So that means the slope is dy dx. Right, got it? Is that down? Right, okay. The next thing is, how do you decide? So that's how you find the turning points. And I'll do an example in a minute, how you find the turning points. Right, now how do you decide whether it's a max or a min? Right, you can draw them in your head, which is normally how I do it. Right, I draw it in my head, and the one that's up high is the max and the one that's down low is the minimum. Right, but there's an official way to find it. Okay, and the official way to find it is, they're called the nature of the turning point, means is it a max or is it a min? Right, and the rule for the nature of the turning points, girls, is you get d2y dx2, right? And if that's less than 0, right, it's the maximum point. So it's the opposite to what you think it was, right? So you get d2y dx2, so you differentiate again and you fill in the x value. And if you get a number less than 0, that makes it a maximum point. And when you get d2y dx and you fill in for x and you get a number that's greater than 0, it's the minimum point. You need to remember these rules. Okay, so I'm going to do an example. Right, okay, so you know what the hell I'm talking about. So I'll leave you write down the example and then we will go do it. How am I going for time? Yeah, I'm okay. Are we good? No. Are we good? Everyone down? Everyone with me? Right, okay. So here's the curve, right? And it said find the turning points. So immediately I write down the rule. At the turning points, TP stands for turning points. dy dx equals 0. So what will I do? I get dy dx. So what is dy dx of this curve, please? It would be 3x squared minus 18x plus 15. So I'm going to let that equal to 0 and I'm going to solve, right? Because I want to know where is the slope equal to 0, where is dy dx equal to 0, right? In order to make it easier for me to find the factors here, everything divides by 3, doesn't it? So I'm just going to divide everything by 3. So I get x squared minus 6x plus 5 equals 0. Then I'm going to factorize x and x, 5 and 1, a minus and a minus. Okay? Then I'm going to let each bracket equal 0. So I get x equals 5 and I get x equals 1. Now they asked me for the turning points, right? So I need y values. Okay? So I get the y values, girls, back up at the very top. So I have to go back up to the very top curve where it's y is equal to x cubed minus 9x squared plus 15x plus 2, right? So everywhere I see an x, I'm putting in a 5, so that means y is equal to 5 to be cubed minus 9 times 5 to be squared plus 15 times 5 plus 2. 125 minus 225 is minus 100 plus 75 is minus 25. I think it's minus 23, but I'm open to correction on that. Okay, right, so that point is 5 minus 23. Is that okay? And then I have to get a matching y for this x. So that means y is equal to 1 to be cubed minus 9 times 1 to be squared minus 15 times 1 plus 2 into the calculator. With that would be minus 8 minus 23 plus 2 minus 21. No, that's a plus, so it wouldn't be minus 21. Minus 1 minus 9 is minus 8 plus 15 is 7. It's 9. Okay, so that's 1, 9. And as I say, I'm open to correction on those calculations, right? So there are my two turning points. See it? Okay, now I have to determine the nature of the turning points, right? Okay, so I'm going to do it unofficially and then I'll do it how you do it officially, right? So unofficially, if I was to draw 523, I'd go across to 5 and down to minus 23, wouldn't I? And if I was to do 1, 9, I'd go across 1 and up to 9. So which one's up high and which one's down low? 1, 9 is up high, isn't it? So this is the max turning point and this is the min, right? Okay, but sometimes they ask me to prove it, right? Okay, so how you prove it was the second rule, is you get d2y dx2. So d2y dx2 means you differentiate again. So remember we did this in the first chapter and we had no reason to differentiate again, but now we do, right? d2y dx2 means you take dy dx, which is here. dy dx is 3x squared minus 18x plus 15. You differentiate again and we'll get 9x minus 18. No, you wouldn't. You get 6x minus 18. Thanks, that's a test you passed. Right, okay, right, and then you check it out at both points. So at the point, the turning points are 5 minus 23 and the other one is 1, 9. So all I do is fill in for x. So at this point x is 5, so 6 times 5 minus 18, that would be 12, right? Which is greater than 0. So when d2y dx2 turns out to be greater than 0, that's the minimum turning point, right? And yeah, then the other one, you fill in x is 1, so you get 6 times 1 minus 18, which is minus 12, right, which is less than 0, which means the rule is if d2y dx2 turns out to be less than 0, turns out to be a negative number, that means it's the maximum turning point. Is that okay? Oh, no, you get full marks, but sometimes they ask you to do it out to show using d2y dx2. So you have to know about the rule, but you don't have to use it unless they ask you. Right, you all hear that? You don't have to use it unless they ask you to use it, as in you can visualize it and call one the max and one the min, right? But sometimes they ask you to use d2y dx2 to show, because you have to know about the rule. So that's why I'm telling you about the rule. Is that okay? But you don't have to use it unless they ask you to. Is that alright? Yes?
Would there ever be like an instance where both your answers were greater than 0?
No. Right, example 2. Right, so I'm still on the turning points. Right, just one that takes a bit more work. Right, okay. So here's a function, y equals ax cubed plus bx squared plus c, right? It has a turning point at 0, 4 and a minus 1, 5. So it's a cubic equation, look. Right, so it's a cubic equation. One of the turning points is at 0, 4 and the other one's at minus 1, 5. And I've those done the wrong way around, don't I? Right, okay, so I'm just going to rub out that. Okay, but just to show you, it's a cubic equation, right, okay? It's got a max and a min, right? It's got 2 turning points. And one of them happens at minus 1, 5. The other one happens at 0, 4. Right? Is that okay? That's what they're telling me. And they said, find A, B, and C. This is very similar to one I did last night, except what I do first, it goes through the point 0, 4. Right, that curve goes through the point 0, 4. So everywhere I see an x, put in a 0. Everywhere I see a y, put in a 4. So this is even before I'm going anywhere near dy dx. I know it goes through 0, 4. Right, so instead of that y, I'm putting in a 4. Instead of all the x's, I'm putting in a 0, 0 to be cubed, plus b times 1 to be squared, 0 to be squared, plus c, right, and that just works out c is equal to 4. So I haven't gone near dy dx and I've already figured out what c is, right? It also goes through the point minus 1, 5. So that means I'm going back up there. Everywhere I see an x, I'm putting in a minus 1. Everywhere I see a y, I'm putting in a 5. So 5 is equal to a times minus 1 to be cubed plus b times minus 1 to be squared plus c. I've already figured out c is 4, so plus 4. Is that right? Okay, so rearranging that, that would be minus a plus b equals 1. Yeah. Okay, is that right? I can't go any further with that. Okay, because that's an equation in 2 unknowns. Right? So the next, I have to work with the next piece of information I know. And the next piece of information I know is dy dx, or I know the turning points. So at the turning points, right, at the turning points, dy dx equals 0. So let's get dy dx. So dy dx is 3ax squared plus 2bx differentiate C and you get 0. So I know that equals 0. So that equals 0 at 2 points. So at 0, 4, that's true, isn't it? And at minus 1, 5, that's also true. Yeah? So at 0, 4, right, I'm going to put in x is 0. That's not helpful. Why? Because if I just put in x is 0, 0 to b squared plus 2 times b times 0 equals 0, and I end up with 0 equals 0, so that's not a helpful statement. Sure it's not? Okay, right, so let's use the other turning point. So dy dx is 3ax squared plus 2bx, and I know that equals 0 at the other turning point also. The other turning point was what? Minus 1, 5. So all I have to do is fill in the x. So the x is minus 1. So it's 3 times minus 1 to be squared plus 2b times minus 1 equals 0. So that will get me 3a minus 2b equals 0. There's my second equation for simultaneous equations. Okay, so then I go back. So it's 3a minus 2b equals 0. The other one is, I'm going to multiply the other one by 2. It's minus 2a plus 2b equals 2. When I multiply it by 2, there you go, and you get a is equal to 2, right? Okay, and then find out b. So 3a minus 2b equals 2. So I've just a is 3 times 2 minus 2b equals, that should be equals 0, shouldn't it? Right, and I end up, when I solve all that, I'll end up with b is 3. So a is 2, b is 3, c was 4. Is that alright? Okay. I wanted to do point of inflection, but I'm obviously not going to get it done now. So I'm going to give you your homework, right? Okay, but I had the homework decided on before I did point of inflection. So if any of these questions mentions points of inflection, don't do it. So do page 110 to 111, 1 to 12, except number 4, 9 part 2. Actually, except number 4, all of number 9, because that's point of inflection, and number 11, because I've done those. Okay, so 1 to 12, except 4, 9, and 11. Okay. Thanks so much.